2007, question number 6 on the AP Calculus AB exam. Let f be the function defined by f of x equals k times the square root of x minus natural log of x for x is greater than or greater than 0, where k is a positive constant. Find f prime and f double prime. So hopefully this is a review from last chapter. So we'd have k as a number. So think of 5 square root of x. We would write that as 5x to the 1/2. Okay, the 1/2 would just multiply by the 5, and then I'd have x to the negative 1/2. It's the same kind of thing here. I'm going to have k is just out front like a number. I'm going to have 1/2 x to the negative 1/2 minus the derivative of natural log is 1 over x. Okay, so you can tidy it up a little bit. It's k over 2 x to the negative 1/2 minus, I can write this as x to the negative 1. I'm writing it this way so it's convenient for f double prime. Okay, so now k over 2 is just a number, so just pull it out to the front. And my derivative of x to the negative 1/2 is negative 1/2 times x to the negative, subtract 1, so negative 3 over 2. And I have minus negative 1 x to the negative 2. So that becomes plus there. Tidy it up a little bit, so it's negative k over 4 x to the negative 3 over 2 plus x to the negative 2. Okay, you can leave negative exponents in your answer, so I wouldn't waste time trying to write 1 over x, under a square root, raised to the third, all of that. Okay, so B says, for what value of the constant k does f have a critical point at x equals 1? Okay, so a critical point comes from when x is, or when the function f is undefined, or f prime equals 0. So when f prime is undefined or f prime equals 0. Okay, so that's what I'm worried about. Okay, so for f prime, I want to find when it's equal to 0. So I'm going to have k over 2 x to the negative 1/2 minus x to the negative 1. Okay, in this case it might be a little easier to look at it with denominators. So this is 2 square root of x minus 1 over x. Okay, so already I can tell it's undefined when x equals 0. So this is a critical point. Oh wait, sorry. It says at x equals 1. So I guess not when x is equal to 0. Okay, so we're going to ignore that. So when x is equal to 1. So go ahead and plug in x equals 1. So I get k over 2 times 1 minus 1 over 1 equals 0. So I have k over 2 minus 1. So 1 equals k over 2. So k is equal to 2. So this is the value where your slope is undefined, or when your slope is equal to 0. F prime equals 0. So for this value of k, determine whether f has a relative minimum, relative maximum, or neither at x equals 1. Justify your answer. Okay, so if k is equal to 2, let's write what f prime of x is equal to. So f prime of x would be 2 over 2, so x to the negative 1/2 minus x to the negative 1. F double prime of x, if k was equal to 2, would be 2 over 4, so negative 1/2, x to the negative 3 over 2, plus x to the negative 2. Okay, so we need to figure out what's happening at x equals 1. So if I have f prime of 1, so it's a prime, not a double prime. So at f prime of 1, I have 1 to the negative 1/2, so that's 1 over the square root of 1, which is 1, minus 1 over 1, so I get 0. F double prime of 1 is negative 1/2 plus 1, so that's 1/2. So the important thing is that f double prime is positive, f prime is equal to 0. So that means that I have so if it's positive, that's concave up, and f prime is equal to 0, you have a minimum. So you would write f, so always be specific, so f has a relative minimum, or local min, at at x equals 1 by we call it the second derivative test. So if you didn't know what it was called, then you could say f has a relative minimum at x equals 1 because f prime of 1 is equal to 0 and f double prime of 1 is positive, and that would be enough justification. Okay, part C. So it says for a certain value of the constant k, so it's no longer 2. The graph of f has a point of inflection on the x-axis. Okay, so it's on the x-axis, so what that means is that y is equal to 0. You would get 1 point for just writing that y equals 0, or you could just get, or if you had written f double prime of x equals 0. So if you had either of those things, you would get 1 point. Okay, so we knew that f double prime of x equals 0 because it said graph of f has a point of inflection. So that means the second derivative is equal to 0. All right, so let's figure out. So the second derivative equals 0, and y equals 0. So let's go back in our original. And if y is equal to 0, that means f of x is 0. So you have k. Well, that brings up a good point. I probably shouldn't call this y. Let's go ahead and call it f of x. So f of x equals 0. Okay, so I get 0 equals k times the square root of x minus natural log of x. And f double prime of x equals 0, so that means that negative 1/2 x to the negative 3 over 2 plus x to the negative 2 equals 0 as well. Okay, let's solve for k. So if I solve for k in the first one, I'm going to have natural log of x equals k times the square root of x. So k is going to be the natural log of x over the square root of x. Okay. If I solve for the other one, oh, you know what? In this other problem, I've used k equals 2. I didn't use my correct second derivative. Hopefully you guys caught that. Okay, my second derivative was up here. So these were when k is equal to 2. Okay, so I have negative k over 4 x to the negative 3 over 2 plus x to the negative 2. So let's write it in a different form. So this is negative k over 4 x to the 3 over 2 plus 1 over x to the 2 equals 0. So that might help a little bit. If I need to get common denominators, I need to multiply by 4. Well, I guess I don't need to. Let's just add the k over 4x to the 3 over 2 to the other side. You could get common denominators pretty quickly. So we have that. You can cross multiply. So you get k x squared equals 4x to the 3 over 2, and we're going to divide by the x squared. So I get k equals 4x to the 3 over 2 divided by x squared. So I subtract my powers. So it's 4. I have 3 over 2 minus 2, so negative. So 4 times x to the negative 1/2. In other words, 4 over the square root of x. Okay, so I've solved for k in 2 different ways. So if I want to know what value of k this works for, I'm going to plug it in. So I'm going to say natural log of x over the square root of x equals, so I substitute. So instead of having k, I'm going to plug in the 4 over the square root of x. So in other words, natural log of x equals 4. So x is, natural log is log base e. So if I switch to exponential form, it's e to the 4 equals x. So e to the 4. Okay, go back and look at our question. So it says for a certain value of the constant k. So that's our certain value for x, not for k. So we have found that location on the x-axis. So the question is, how do I find what k is? So you can use either equation. So I think it's pretty easy in the first one, this one. So I have natural log of e to the 4 over the square root of e to the 4 equals k. So it's 4 over e squared equals k. That's your value of k that we were looking for.